Alright, and we're back. So after making my first video for this series, I realized I can't make this longer than 10 minutes, which is actually perfect because that's pretty much, as you saw from yesterday, exactly kind of my bike commute. So it'll be bite-sized education on climate change, rather just a chat, just a fun chat. I don't like the word education sometimes. It sounds a little dry. So, all right, let's get into the big picture when we bring up climate change. What is climate change? So, it's pretty much a broad, encompassing word, right? Describes a lot. I just got a bug in my eye. Maybe I should wear my sunglasses. Oh, that sucks. Anyways, climate change is a big encompassing word that kind of describes the weather or temperature. You got ice caps melting or freezing, oceans rising. It just kind of like the changes over long periods of time. So a lot of people get confused. A lot of confusion over climate and weather. So climate is the study of long-term trends. I'm talking about decades, centuries, that kind of thing, in our kind of patterns in our weather system and stuff like that. Weather itself is short-term things that just happen over a day, a week, a month. So sometimes you can have just freezing ass cold weather. Doesn't mean climate change is still happening, because it's just you're taking that down into a very minute amount of time. But if you look at the big picture, things are definitely changing. So that's what climate is in a nutshell. Up on some leaf blowers. Sorry, loud noises. Alright, so cool thing. So this is one of the things I found out that I love, is the way that scientists study climate change. Is they take these big metal tubes and they shove them down into the ice, like big glaciers of ice. So the Arctic and Antarctic, Greenland. They can also do this with ocean sediment. So they'll go into the oceans and stick these big tubes into soil sediments, like deep into the ocean. And what they can determine a lot of stuff with these. So they shoot a big tube in the ground, and then they pull it back out, and in the middle is an ice core, or I guess they just call it a soil core. So you get this core, and it's just a kind of a big tube of ice, and within that they can measure the isotopes of different elements over centuries of time, even thousands, even longer than centuries, thousands and thousands of years. I think the longest ice core records actually go back like 800,000 years. Again, I'm going to make this blatantly clear. I am not a scientist. I've done a lot of research, but if you want to get the exact numbers, I urge you to look up those numbers yourself and educate yourself. Again, this is just a chat about what I've kind of my experiences and what I've learned. But yeah, ice cores are really cool. So not only isotopes, they have lots of air bubbles in them. And based on like the size of those bubbles and the quantity of those bubbles, they can actually tell how much carbon dioxide, how much other greenhouse gases were in the atmosphere at that time in history. And so we have a large data table for, going back hundreds of thousands of years. And over that time, of course, there's been a lot of changes in greenhouse gas levels. And I'm going to talk about greenhouse gases in another video, probably the next video actually. But they have records of greenhouse gases going up and down and up and down. And there's been several points in history where they've changed drastically, and we see what we're seeing today, where the ice caps melted and temperatures rose. And actually, most of the mass extinctions on our planet, there's been 5, I'm pretty sure, prior. And I think, again, do your own research. Don't just take me at my word. I want people to educate, get educated. Educate yourself. So, where was I going with that? Okay, yes. So, I think 4 out of those 5 mass extinctions are all related to carbon dioxide levels in our atmosphere, relating to huge volcanic explosions and creating mass amounts of volcanic dust over the atmosphere, things like that. So people can, there's like arguments, saying, well, we've seen that in the past. The weird thing, this right now we're seeing, and I'm gonna, again, touch on this when I get to greenhouse gases, but we haven't seen the rate, the level to which the climate is changing right now has never been seen before in records, in those 800,000 year plus records, and they have other ways to tell. We have records going past 800,000 years, I believe, past the ice cores, but that's probably one of the most reliable. But so yeah, so imagine a mountain. Okay, we have never seen, and the mountain is the rise and climb of the mountain is related to the rise and climb of carbon dioxide change or greenhouse gas change in our atmosphere. So we've seen huge mountains in the past, but we have never seen a mountain that is as steep as the one we are in currently, and that's scary. So I'm almost finishing up my ride here. I want to, at the end of each one of these videos, just get like a suggestion, my hasty suggestion on ways to kind of like improve, ways you can help. So with this one, I just say, go check out stuff online, check out pictures of ice cores, educate yourself a little bit on that wavelength history of greenhouse gas change related to ice cores. If you Google something like that, you'll find a really interesting graph, I promise you. And that's it for today, guys. All right, I'll check you out later. Peace.